Hello friends, I hope you all are having a great day. Today I am going to talk about selection sort. It's something you can learn easily, so without further, let's go get straight to it. First I want to mention that is my unsorted array. Okay, that is my unsorted array. I assume that the first element is the minimum number. What is the first element of this array? 12. Okay, let's assume it as 12. Okay. Now we will check 12 against every other number. First we check it with 6. Check with 6. And you can see that 6 is less than 12. So now our minimum number is 6. Let's continue checking 6 against other numbers. Check with 7, check with 8, check with 10, check with 2. Okay. Now you can see 2 is less than 6. So now our minimum number is 2. Then we check 2 with 9, and since 9 is greater than 6, our minimum remains 2. Now we swap 2 with 12. Okay. Now this is sorted part and this is unsorted part. Okay. In the first pass, we do 6 comparison. Okay, we do 6 comparison. 1, 2, 3, 4, 5, 6. Okay. Now our array is divided into two parts, the sorted part and the unsorted part. This is sorted part and this is unsorted part. We will take the first element of the unsorted part as a minimum, which is 6. Okay. And I check 6 with other numbers. Check with 7, check with 8, check with 10, check with 12, check with 9. Okay. Okay. Since there are no number less than 6, it remains in its place. In the second pass, we make 5 comparison. 1, 2, 3, 4, 5. Now 6 is sorted. Now this is our sorted part and this is our unsorted. Next, we take 7 as the minimum number. This is our unsorted part. First element of the unsorted part is the minimum number. So 7 is the minimum number. Okay. And check it. Check with 8, check with 10, check with 12, check with 9. Okay, you can see with the since there's no number less than 7, it remains in its place. Okay. In third pass, we made 4 comparisons. 1, 2, 3, 4. Okay. Now 2, 6 and 7 are already sorted. Okay. The best element of the unsorted part is 8. Okay, now check with another number. Check with 10, check with 12, check with 9. Okay. After checking, we find no number less than 8. So it is stay in its place. Okay. So 8 is sorted. Already sorted. In the fourth pass, we made 3 comparisons. Okay. 1, 2, 3. Okay. Next, we take 10 as the minimum and compare it with the remaining numbers. Check with 12, check with 9. Okay, we find that 9 is the less than 10, so our minimum becomes 9. Minimum becomes 9. After swapping 9 with 10, or after I'll do it. And then in the fifth pass, we made two comparisons. Made two comparisons. Okay. Now 9 is sorted. You see, I have 10 and 9. Okay. 10 and 9. So 9 is here, 10 is here, 9 is sorted. Okay. Finally, we this is sorted part and this is unsorted part. Finally, we take 12 and compare with 10. Our minimum becomes 10. Okay. You can understand. We check 12 with 10. So 10 less than 12, our minimum becomes 10. So we swap 10 with 12. Okay. Now this is the sorted part and this is the unsorted part. Okay. In the sixth pass, we made one comparison. Okay. One comparison. Now only one element 12 remains. We don't need to check it and our array is now sorted. Now you can see our array is now sorted. This is the sorted array. So you must have understand the process to get a deeper understanding. Let's look at the algorithm. In this, D is taken as the complete array. Its complete size means that the number of elements can be taken as n. Next we need to go from I equals 0 to n. Okay. I equals 0 to n, which means we need to go from the index 0 to the complete n, because we have to go through its element one by one. Okay. As the minimum value, we take the first element of the unsorted array and then we compare the values after the first element. Right. So we start with j equal I plus 1. Okay. Then we get a number less than the number we took. If we get that, we change the value of this variable. Okay. Here we change the index. Okay. Finally, that minimum value and the first element in the unsorted array are swapped. In this way, that's what we have done here completely. Okay, so I think it's clear to you. So when we look at this with a little light, we can say about its time complexity. Then here we have taken a total of 7 elements. Okay? Total of 7 elements. We can see the number of comparisons that have to be done for 7. 6 plus 5 plus 4 plus 3 plus 2 plus 1. Okay. We can get like this. If we generally assume that there is an amount of n, we can write this as n minus 1, this way, right? 2 plus 1. Okay. So we can write this as dividing n times n minus y by 2. I'll write it n times n minus 1 divided by 2. Okay. Then there is a time complexity of order of n square. This is the time complexity of this. That's it. So this is all about the selection sort. I will say goodbye until we meet in the next video. Thank you.